All right, we're going to work on our next math formula, which is calculating drip rates. So this is if I'm giving a patient a fluid bolus, and I want to calculate how many mLs or how many drops per minute that I'm going to give. So if I don't have an IV pump, I'm actually needing to watch the drips go through the drip chamber to calculate how much I'm going to give to that patient. So make sure you watch the video on introduction to infusion sets or IV drip sets, so you kind of understand how a IV drip set works before you tackle this formula. So I put some things up here. So the formula, of course, we're going to use dose ordered times drip factor over time, and your dose ordered has to be in mLs because your drip factor is going to be in mLs, and your time has to be in minutes because we're going to be counting drips per minute, not drips per hour when we're trying to set up our drip rates. Some of the drip sets we typically use, mostly you'll see the 10 drops per ml and 15 drops per ml sets. And what that means is we have to watch 10 drops actually go through that drip chamber before an ml actually gets into our patient. The 20 drops per ml sets are common for IV set or IV pump sets. So sometimes we may get these when we're restocking at the emergency room by accident. But we can still use them as a gravity drip set. They work just fine without the IV set. Just has a different drops per minute. And then we also have our micro drip sets, and those are the drip sets that we use typically for giving medication. So we'll definitely get familiar with micro drip sets when we start talking about dopamine and epi infusions. But those have the needle in the middle, and it's just a little more easy to calibrate because we're giving the 60 of those drops equal 1 ml. So we can control the flow rate a lot easier. I did put here KVO, so a lot of times you may see that we're going to leave the saline at KVO. That just means a slow drip, and that really just maintains the patency of our IV, so we don't get any clotting or obstructions in our IV catheter. And really in real life what we're doing is we're just kind of setting up the rate very slow, because we don't necessarily want to give our patient a bolus of fluid, but we want to maintain the patency of that IV. So we'll play around with that a little bit. You don't have to memorize this value. It's just a value that we put in our IV pumps if we want to say we want to keep it KVO. Remember, our final answer is always going to be a whole number, and that's because when we're counting drops, we're trying to set a drip rate, so we're counting how many drops we're giving in 1 minute. We can't give a fraction of a drop. So this kind of makes our math easier. If you do end up with a decimal, you only need to find your answer to 1 decimal place because we're going to round to the nearest whole number. So let's look at our first problem. Our patient requires 120 mLs per hour of saline through their IV. We have a drip set that's 15 drops per ml. How many drops per minute will the patient receive? So I'm going to first write out my formula like I always do. Dose ordered times drip factor over time, and then let's go ahead and assign our values. My dose ordered, I want to give 120 mLs. My drip factor, I have a 15 drop per ml set. And then my time is an hour, so in minutes it's going to be 60 minutes. And now I can just plug these into my equation. So 120 times 15 over 60. Now I have some zeros at the end of my numbers here, so I'm going to simplify to make my math a little easier. And that leaves me with 12 times 15 divided by 6. 2 times 5 is 10. 2 times 1 is 2, plus 1 is 3. 1 times 5 is 5. 1 times 1 is 1. And I add those columns together. So now I have 180 over 6. So 6 goes into 180. 6 goes into 18 3 times. And that equals 18. Remember, I do have to finish out the zeros. You know, 6 goes into 0 0 times. So this one was pretty easy. We don't have any remainders. And I got 30 drops per minute. So that's how many drops per minute I'm going to deliver to my patient in order to be delivering this delivering this dose of saline. So when it comes to actually measuring this out, I'm going to go ahead and use my drip chamber, the dial on the drip chamber, and I'm actually going to count 30 drops per minute. And an easy way to do that is there's 60 seconds in a minute. So 60 divided by 30 is 2. So I'm going to give 1 drop every 2 seconds. So I'm actually going to count out loud 1, 2, drop, 1, and that way. So it's not an exact science, but it's a good way to figure out how much you're giving to your patient. Not something that we use commonly, but I have had to use this before when I've worked actually recently in a field hospital, and we didn't have IV pumps, and we actually had to figure out our drip rates by gravity tubing. All right, let's look at our next one. So this one, let's go ahead and write out our formula first. So I got my dose ordered times drip factor over time. My dose ordered, I want to give KVO, and if we look up there, KVO is going to be 20 mLs per hour. Drip factor, I have a 15 drop per ml set. And then time, we already looked as 20 mLs per hour, so it's going to be 60 minutes. So now I can go ahead and plug those numbers into my equation. I've got, sorry about that, 20 times 15 over 60. Let's go ahead and get rid of some zeros to make our math simpler. So 2 times 15 equals 30 over 6. 6 goes into 30 5 times, and that equals out. So I'm going to give 5 drops per minute. So in order to figure out if I was trying to count this out, how many drops per minute I'd give my patient, I would just take 60 divided by 5, which is 12. So I'd give 1 drop every 12 seconds when I'm setting up this drip rate. All right, next one. Patient requires saline. We're still going to do the KVO rate, which is 20 mLs per hour. And we have a 10 drop per ml set. So dose ordered times drip factor over time. My dose ordered is going to be 20 mLs. My drip factor is 10 drops per ml. And my time, it's per hour, 1 hour, 60 minutes. So now I'm just going to plug these numbers into my equation. I have 20 times 10 over 60. So we can go ahead and cross out some zeros. So I have 20 divided by 6. 6 goes into 23 times, which gives us 18. I got 2 left over. So here I do need to find my decimal because I have a remainder. And since we're rounding to a whole number, I only need to find 1 decimal place. So 6 goes into 20 3 times. So if I round that to the nearest whole number, that's going to be 3. So I'm going to give 3 drops per minute. So I would be giving 1 drop every 20 seconds. So very, very slow. All right, let's look at the next one. It's going to be a little more complicated. Patient wants 500 mLs over 2 hours, and here's our drip factor. So dose ordered times drip factor over time. My dose ordered here is going to be 500 mLs. My drip factor, 10 drops per ml. And my time here is 2 hours, so I need to put that into minutes. So I got 2 hours, there's 60 minutes in an hour, 2 times 60 equals 120. So now I'm just going to plug those numbers into my equation. 500 times 10 over 120. And we can simplify this a little bit. So I have 500 times 1 over 12, which is the same thing as 500 times 12, because 500 times 1 is 500. So 12 into 500. 12 goes into 50 twice. I'm sorry, goes into 54 times. I had to think about that. I was like, that doesn't look right. Which equals 48. 12 goes into 20 one time. And we have a remainder of 8. So we do need to find my decimal here. 12 goes into 86 times. And that's going to equal 72. And I only know that because all my 12-hour shifts. But I can go ahead and stop here because I only need to find one decimal. So if I round this to the nearest whole number, it's going to be 42. So I'm going to give this patient 42 drops per minute. All right, patient is going to get 75 mLs per hour, and we have a micro set now. That's 60 drops per ml, which is our micro tubing. So my equation, dose ordered times drip factor over time. My dose ordered here, I'm going to give 75 mLs per hour. My drip factor, I have micro tubing, so it's 60 drops per ml. And my time, it's over 1 hour, which is 60 minutes. Now I'm going to plug these numbers in. 75 times 60 over 60. So this one's actually very easy to reduce. I have 60 on top and 60 on bottom. We're just going to cancel them out and get rid of them. So no, not really any math involved here. We're going to give 75 drops per minute. All right, looking at the next one, let me write out my equation. Dose ordered times drip factor over time. I want to give the patient 800 mLs. So that's my dose ordered. I have micro tubing. So my drip factor equals 60. And I want to give it over 4 hours. So we need to change that to minute. So 4 hours times 60 minutes per hour, it's going to get 240 minutes. So we're going to go ahead and plug these in. I've got 800 times 60 over 240. So let's go ahead and cancel out those zeros. I'm going to figure out what 800 times 6 is. So I know that 8 times 6 is 48, and I'm going to add 2 zeros on the end of that. So I end up with 4,800 divided by 24. "24 goes into 48 twice. Now I need to finish this out and bring down my zeros to fill in my places. 24 goes into 0 0 times. 24 goes into 0 0 times. So that leaves me with 200 drops per minute, which would be pretty hard to measure out. We would probably just run that wide open at that point. All right, patient requires 1,000 mLs over 6 hours, and we have a 15 drop per ml set. So dose ordered times drip factor over time. My dose ordered, I want to give 1,000 mLs. My drip factor, I have a 15 drop per ml set. My time on this one's a little different. I want 6 hours. So I got 6 hours times 60 minutes in an hour. It gives me 360 minutes. So we'll go ahead and plug these numbers in. 1,000 times 15 over 360. Let's get rid of some zeros. 15 times 100 equals 1,500 over 36. Now this one you may have to do some guessing on this to figure out how many times 36 goes into 150. So I'm going to try over in my margin here. 36 times 3. See how close that gets me. 3 times 6 is 18. 3 times 3 is 9, 10. So 108, I need a little bit more than that, actually. So 36 times 4. 6 times 4 is 24. 4 times 3 is 12, plus 2 is going to be 144. That's definitely as close as I can get. And that's okay to have to test out these numbers. You know, obviously I don't know my 36 multiplication table, so we're just going to have to, you know, try a few numbers and see. So that gives me 6 left over. Now I do know that 36 only goes into 60 one time. Ten minus 6 is 4. Leaves me with 24 left over. I need to add my decimal because I do need to find one place. And now I have 36 into 240. So again, I'm going to have to test this out a little bit. I know that 36 times 4 is 144. Times 5 is only going to be around like 170, 180. So I'm going to try times 6. 6 times 6 is 36. 6 times 3 is 18. Plus 3 gives me 216, and that's definitely as high as I'm going to be able to go. So I can actually stop here because I found my one decimal. So I'm going to round this to the nearest whole number, and it's going to give me 42 drops per minute. So that one was definitely a little more complicated. Moving on to number 8. We have patient requires 250 mLs per hour. We have a 20 drop per ml set. So dose ordered times drip factor over time. My dose ordered, I want to give 250 mLs. My drip factor, I have a 20 drop per ml set. And my time, it's over 1 hour, so it's just going to be 60. So I got 250 times 20 over 60. Get rid of some zeros there. So 250 times 2 is 500. Divided by 6. So I know that 6 goes into 50 8 times. Gives me 48. 6 goes into 20 3 times, which gives me 18. And gives me 2 left over. So I do have a remainder, so I have to add that decimal. 6 goes into 23 times. So I can stop right there because I have one decimal and I'm rounding to the nearest whole number. So I'm going to give 83 drops per minute. Alright, this next part, I just threw some weight conversion practice on there, just to kind of refresh our memories a little bit. So let's go ahead and work through these problems. And the first one, we're just changing kilograms to pounds, which is a little bit easier. So your pounds equals your kilograms times 2.2. So we're going to do 85 times 2.2. 5 times 2 is 10. 2 times 8 is 16, plus 1 is 17. Make sure you add your 0 to your column. 2 times 5 is 10. Still got that remainder. 2 times 8 is 16, plus 1 is 17. I have one decimal place in my problem, which means I have one decimal place in my answer. So 85 kilograms is going to equal 187 pounds. Alright, I'm going to go ahead and erase some of this so we have some room here. Looking at our next one, I have 102 kilograms. I'm changing to pounds. So pounds does equal kilograms times 2.2. So we're going to do 102 times 2.2. 2 times 2 is 4. 2 times 0 is 0. 2 times 1 is 2. make sure for the next column you are putting in your placeholder 0. 2 times 2 is 4. 2 times 0 is 0. 2 times 1 is 2. Add my columns together. I have 1 decimal place in my problem, so I'm going to have 1 decimal place in my answer. So 102 kilograms equals 224.4 pounds. All right, next one, we're still going from kilograms to pounds. Make some room. So I'm still going to be using this same formula up here. So I want to take 28, which is my kilograms, times 2.2. 2 times 8 is 16. 2 times 2 is 4, plus 1 is 5. Put my 0 for my placeholder. 2 times 8 is 16. 2 times 2 is 4, plus 1 is 5. 6 plus 0, 6. 5 plus 6 is 11. Carry over that 1. 1 plus 5 is 6. I have 1 decimal place in my problem, so I'm going to have 1 decimal place in my answer. So 28 kilograms is equal to 61.6 pounds. All right, now we get into the more tricky ones. We're going from pounds to kilograms. So we know that to do this, we're going to take our pounds, kilograms equals pounds, divided by 2.2. So we have 280 pounds divided by 2.2. All right, so I want to move this decimal place over so I don't have to worry about decimals. If I move it over one there, I have to move it one over there. So that actually gives me 22 into, and I erased the whole thing. Let me just rewrite it. So it actually gives me 22 into 280 plus a 0, so 2,800. Because we've moved that decimal place over one here, I need to move it over one here, which means I need to add a 0. 22 goes into 28 one time. I get 6 left over. 22 goes into 60 twice. I have 16 left over. 22 goes into 160 7 times. And this is where you may need to play around with some numbers. You may have to off in your margin go 22 times 5, 22 times 6, see what they equal. I've just done so many of these problems, I know my 22 times tables by now. But it's certainly okay to just off in the margin, kind of test out a few numbers. But 22 times 7 is 154. So I have a remainder of 6. And remember, with these problems, we're finding to the nearest tenth, which means I need to find my answer to the 100th so I can round appropriately. So go ahead and just put 2 zeros. If you had to add a decimal, go ahead and put 2 zeros in that place so you know that there's 2 zeros you need to bring down and you don't forget. 22 goes into 60 2 times. Sorry, that's supposed to be 44. So you get a remainder of 16. Looks pretty familiar. Goes into 160 7 times. All right, so this is why it's really important that we find to the nearest 100th to round to the nearest 10th. Because if I had stopped at 127.2, my answer technically would have been wrong. Because when I round to the nearest 10th, I get 127.3 as my answer. So 280 pounds equals 127.3 kilograms. That's what we're going to get for our answer. All right, we got a couple more. So I'm going to erase some of this stuff. We have room. All right, now I have 70 pounds into kilograms. So I'm using the same formula up here. I need to take 70 and divide it by 2.2. So when I set up my bracket, I'm going to move this over a space, which means I'm going to move this decimal over space too. So I have 22 into 700. I know that 22 goes into 70 3 times, which gives me 66. Bring down the 0. I have 22 into 40. It only goes in 1 time. All right, so I have a remainder of 18, which means I need to add my decimal. Go ahead and put 2 zeros there since we're finding to the nearest hundredth. 22 goes into 180 8 times. 22 times 8 equals 176. Running out of room. And I know that 22 goes into 40 1 time. So I get 31.81. I'm going to round to the nearest tenth, which gives me 31.8 kilograms. So 70 pounds. Sorry about that. My dogs just went crazy for whatever reason. Get back down here. So our 70 pounds is equal to 31.8 kilograms. All right, I'm going to go ahead and erase this so we can work our last problem. I have 136 pounds and I need to find out how many kilograms that is. So I'm going to use the same formula, pounds divided by 2.2. So it's going to be 136 divided by 2.2. Remember, when I'm setting up my bracket, I'm moving that decimal over, which means I have to add a 0 on the other side. So I have 22 into 1,360. So 22 can't go into 13, but 22 can go into 136. It goes in 6 times. 22 times 6 equals 132. So I have 4 left over. 22 goes into 40 1 time. That gives us 18 left over, so I do need to add a decimal. 22 goes into 180, and again, you're going to have to play around with some numbers, but it's going to go in 8 times, which gives us 176. Now we're running out of room here, so I'll try to make that bold. 22 goes into 40 1 time. So I'm going to round this to the nearest tenth. So I'm going to get 61.8. So 136 pounds is equal to 61.8 kilograms. All right, next we're just going to work out some fluid bolus problems. So I want to give my patient 20 mLs of saline per kilogram, and that's a normal fluid bolus that we give a patient. So if I have a patient that, say, is like hypovolemic and I want to do fluid replacement, I'm going to give 20 cc's per kilogram, reassess my patient, and then I can go on with another 20 cc's per kilogram. So that's how we kind of fluid resuscitate our patients. But I want to figure out how much that's going to be. So I want to give 20 mLs, which is the same thing as cc, of saline. The patient weighs 70 kilograms. So I'm just going to take 20 mLs times 70 kilograms. Is going to be my dose for the patient. 2 times 7 is 14, plus 2 zeros. I want to give that patient 1,400 mLs. So really, a 70 kilogram patient is your typical average size adult. So giving a liter of fluid in times of resuscitation is totally appropriate for this patient. So a lot of times we don't figure out this math, but if we wanted to figure out how much could we give our patient without risking fluid overload, that's how we would figure that out. So this next one, I want to give 20 mLs, the same thing, but the patient weighs 187 pounds. So the first thing I need to do, because it's per kilogram, I need to change this pounds to kilograms. So I'm going to divide that pounds by 2.2. Remember that I moved that decimal over, which means I have to add a 0 on the end on the other side of the bracket. 22 goes into 187, goes in 8 times. I get 11 left over. 22 happens to go into 110 perfectly 5 times. So I don't have anything left over. So this patient weighs 85 kilograms. So now I'm just going to take that 85 times 20. I'm just going to go ahead and put a 0 here because I know that 0 times 5 is 0, 0 times 8 is 0, so I don't need to fill out that first row. 2 times 5 is 10. 2 times 8 is 16, plus 1, 17. So this patient's fluid bolus is going to be 1,700 mLs of fluid. So pretty simple. Just making sure you're figuring out whether your problem gives you a pound or kilograms. That's a really important thing to pay attention to, because a lot of people might read this and they might not see this pounds here, and they might just say, oh, they're 187 kilograms. So just make sure you're looking at the problem. Now we're going to incorporate that into our formula that we learned. So this is a little extra. It's not going to be on the math test, but it's just kind of applicable to like what we would be doing. So I wanted to throw these practice problems in here. So we need to give our patient 10 mLs per kilogram of saline over 6 hours. Patient weighs 76 kilograms, so we're already in kilograms, that's good. Our drip says 10 drops per ml. How many drops per minute will you administer? So we're going to use our same formula, dose ordered times drip factor over time. The thing is we have to figure out our dose ordered. We want to give 10 mLs per kilogram. So our dose order is actually going to be 10 times 76. So our dose order is going to be 760 mLs. So it's just adding that extra step of figuring out what our dose ordered is. Drip factor says that we're going to use a 10 drop per ml set. And our time is going to be 6 hours. So 6 hours times 60 minutes per hour, that gives us 360 minutes. So now we're going to go ahead and plug all this in. We have 760 times 10 over 360. Go ahead and get rid of that. 760 times 1 is going to be 760. So we have 760 divided by 36. Thirty-six goes into 76 twice. 36 goes into 40 one time. So we do have a remainder. And since it's drops, we only need to find one decimal place because we're going to round to the nearest whole number. So 36 goes into 40 one time. So we're going to give this patient, because remember we need to round this to the nearest whole number because we're giving drops per minute, 21 drops per minute. All right, we're going to do the same type of problem, but you'll see here that now our weight's in pounds. So to figure out our dose ordered, because we want 5 mLs per kilogram for our dose ordered, we have to first figure out how many kilograms 84 pounds is. So let's go ahead and work out that first. So we're going to divide 84 by 2.2. So I'm just going to take 22 into 840. I know that 22 goes into 84 3 times, which gives me 66. 14 minus 6 is 8. 7 minus 6 is 1, so I have 18 left over. 22 goes into 180 8 times, which gives me 176. So I have 4 left over. So that's my remainder. So I do need to find, and we're finding out kilograms here, so we do need to round to the nearest tenth. 22 goes into 40 one time. This should look pretty familiar. Oops, I already brought down my 0 because I knew in my head what I was doing. It's going to go in 8 times. So I have 38.18 kilograms. I need to round that to the nearest tenth. So 38.2. Now, still using the same formula. Dose ordered times drip factor over time. My dose ordered, I want to give 5 milligrams per kilogram. So I want to give 5 milligrams per kilogram. So I need to take 5 times 38.2. So you can see where this starts getting a little complicated. 5 times 2 is 10. 5 times 8 is 40. Plus 1 is 41. 5 times 3 is 15. Plus 1 is going to be 19. I have 1 decimal place in my problem, so I have 1 decimal place in my answer. So at least it does give me a nice round number of 191. So my dose ordered is going to be 191 mLs because I want 5 mLs per kilogram. So I figured out how many kilograms my patient weighs, and I multiplied that times 5. And that gives me 191 mLs. The rest of it we can fill in. Drip factor, I have a 20 drop per ml set. And for my time, I'm giving it over 2 hours. So 2 hours times 60 minutes per hour, that's 120 minutes. So now I can plug these numbers in. 191 times 20 divided by 120. I'm going to go ahead and get rid of zeros. So I have 191 times 2 divided by 12. Let's figure out what 191 times 2 is. 2 times 1 is 2. 2 times 9 is 18. 2 times 1 is 2. 3. So I got 382 divided by 12. Twelve goes into 38 3 times. Gives us 36. 12 goes into 22 1 time. So now we have a remainder. I only need to find 1 decimal place since I'm finding drops per minute. 12 goes into 100 8 times. Should be 96. But we can stop right there. I'm going to round this to the nearest whole number. So I'd give 32 drops per minute. So this is just kind of adding in some extra steps. Again, you're not going to be tested on these last 2 problems here. I just wanted you to start working out and seeing how this works in a formula, because when we start going into dopamine drips, we're going to have some of these extra steps in our problems. So I just wanted you to kind of start practicing it and get an idea. Now I did add some extra practice that some people requested in drawing medication out of a vial. So this is not on your worksheet. This is complete extra. So I just threw these problems together. There's not a worksheet that goes along with this, so you can just write out the problems as we go along. But this is for drawing medication out of a vial. So remember our formula for that. We're going to have our dose ordered over dose on hand times volume. So let's look at this problem. I have to give 5 milligrams of morphine, so it's going to be my dose ordered, and the drug is supplied in 8 milligrams and 2 mLs. So when I look at my vial, that means there's going to be 8 milligrams in there in a volume of 2 mLs. But I can simplify this concentration, and I definitely recommend doing that to make your math easier. So if I have 8 milligrams in 2 mLs, I can simplify that because 8 is divisible by 2. That's going to equal 4 milligrams in 1 ml. So I'm going to use this concentration in my problem. So dose ordered, I have 5 milligrams is what I want to give. My dose on hand, I've now simplified that, so it's going to be 4 milligrams. And my volume on hand is going to be 1 ml because I've simplified that. Now you can use this in your problem, but your math is just going to be a little more complicated, that's all. So I'm going to plug these numbers into my equation. I have 5 divided by 4 times 1. So I'm going to figure out what 5 divided by 4 is. 4 goes into 5 one time. I get 1 left over. 4 goes into 10 twice. I'm just going to keep going until I don't have any remainders. 4 goes into 20 5 times, which equals 20, so I can stop there. So I'm going to give this patient, and then we multiply it by 1, but we know that's just itself. So I'm going to give this patient 1.25 mLs. And we can round that to 1.3. I know the test says round to the nearest tenth, but with medications, really, we can draw up 1.25 mLs in our syringes pretty easily, so I'm okay with you leaving it to the 100th. All right, let's look at the next one. We want to give lidocaine 55 milligrams. It's supplied in 100 milligrams and 5 mL. So again, we can reduce this. I have 100 milligrams and 5 mLs of fluid. That's divisible, 100 is divisible by 5. So really I have 20 milligrams per 1 ml. So when I'm looking at that syringe, in each ml, there's 20 milligrams of lidocaine. So I'm going to use this concentration for my problem. Dose ordered over dose on hand times volume. My dose ordered, I want to give 55 milligrams. My dose on hand, I have simplified it. It was 100, but I simplified it down to 20 milligrams. And my volume was 5, but I simplified it down to 1 ml. So I have 55 over 20 times 1, and we can go ahead and just get rid of that times 1 because it just equals itself. So we have 55 divided by 20. Let me erase some of this stuff so we have some room. All right, 20 goes into 55 twice. Gives me 40. Got 15 left over. 20 goes into 150. Well, I know that 7 times 2 is 14. So it's going to be 7 times. Gives me 10 left over. If I bring down one more 0, 20 goes into 100 5 times. It equals 100. So for this patient, I'm going to give 2.75 mLs in order to deliver that 55 milligrams. All right, next one, I want to give 85 micrograms of fentanyl. That's not a normal dose of fentanyl, but I put it that way so we could practice with some numbers and some division. It's supplied in 100 micrograms in 2 mLs, and that is a real concentration for that. So I have 100 micrograms in 2 mLs of liquid. I can reduce that because 100 is divisible by 2. So really I have 50 micrograms per 1 ml. So this is the concentration I'm going to use for my math because it's going to make it a lot easier. So let's set up my equation. I got dose ordered over dose on hand times volume. So my dose ordered, I want to give 85 micrograms. My dose on hand, I've narrowed it down to 50 micrograms. And my volume, I've reduced down to 1. So I have 85 divided by 50 times 1, which we can get rid of the times 1. Alright, so now I just need to do 85 divided by 50. Goes into 85 one time. I got 35 left over, so I need to add a decimal. So 5 goes into 35 7 times, so 50 goes into 350 7 times. So I'm going to give 1.7 mLs to my patient in order to deliver that 85 micrograms. Now that's not a typical dose of fentanyl. Usually we do it in 25, 50, or 100 micrograms, so it's actually it's math that you can kind of figure out in your head. Alright, this next one too, it's a weird dose of morphine, so it doesn't typically come in this concentration, but I just wanted to change around the concentration so we could see how our math is like when we don't get our volume down to 1, because then you know what, we keep getting it down to 1 up here, which makes our math a lot simpler, but sometimes we can't do that. So we're going to play around with this equation. I want to give morphine 8 milligrams, supplied in 5 milligrams and 10 mLs. Now I can still reduce that. 5 milligrams and 10 mLs, we can reduce that down to 1 milligram and 5 mLs. 1 milligram and 2 mLs. I've done too much math for today. Because I'm just dividing by 5. So 5 divided by 5 is 1, 10 divided by 5 is 2. So I'm going to use this concentration because it's still going to make it a little easier. Let's write out my formula. I got dose ordered over dose on hand times volume. My dose ordered is going to be 8 milligrams. That's what I want to give to my patient. My dose on hand is going to equal 1 milligram because I've reduced it down. And my volume is going to equal 2 mLs because I've reduced that down. So plugging these numbers in, I have 8 divided by 1 times 2. 8 divided by 1 is 8 times 2 equals 16. So I'm going to give 16 mLs to my patient. So that one wasn't so bad. Let's look at this last one here. And again, this is going to be one where we can't get our volume down to 1. So we'll have to do this kind of extra step in there. So we want to give 0.5 milligrams of epi, 1 in 10,000, supplied as 1 milligram and 10 mLs. So how many mLs will we administer? I cannot reduce this anymore, so it's going to stay 1 milligram and 10 mLs. Let's go ahead and write my formula. Dose ordered over dose on hand times volume. My dose ordered, I want to give 0.5 milligrams. My dose on hand, I have 1 milligram. In volume, it's in 10 mLs. So I have 0.5 divided by 10. Oops, sorry. It's supposed to be divided by 1. Just thinking ahead. Times 10. So 0.5 divided by 1, 0.5 times 10, which is going to give us 5 mLs, is what we want to give our patient. Hopefully that was helpful for you guys, a helpful little review. If you have any more questions, just let me know.